Okay, welcome to 6-1. This is Piecewise Functions. I think you guys are going to love these. It sounds complicated. It really is not. You'll be given piecewise, which you can always tell is piecewise because you're given a y value, the f of x, the dependent variable with an equals, and then it goes to two or more function rules. And you can just in your mind say this is y equals negative x, y equals x plus 1. And then notice the parameters over here. This is the domain. So this is what you're allowed to plug in. Values less than 0, values greater than or equal to 0. And it'll say like, find the value of f negative 3. Well, negative 3 is less than 0, so you know that you'd be using this one. So when we have a negative 3, the value plugs in there, y equals a negative x, plug negative 3 in there for x, would have a negative 3, so we know that y is 3. F of negative 0.2, that's still less than 0, so we would say, well, a negative 0.2 plugs in, we just multiply it by the negative, that's all that you're doing on that rule, so it would become 0.2. So for these two, we have used the rule f of x equals negative x because they have been less than 0. Now on the next ones, 0 and 2, they fit the parameters of this domain. So x is greater than or equal to 0, then we do x plus 1. So for these, when we plug them in, we're going to have 0 plus 1 is 1. 2 plus 1 is 3. So they fit this rule. Piecewise function is simply two different function rules or more in one graph or in one problem. Now a step function may be seen as this. That means greatest integer function. So what it means is that as you plug these in, you're meeting parameters that are like a step, and it will make more sense here in a minute on the graph. But if I plug in negative 3 for x, negative 3 is equal to or less than negative 2. Okay? So the answer is negative 3. Now what's funny is because it says greatest integer function, the next one will be negative 2, negative 1, 0, and 1. Okay? So negative 2.9, negative 2.9 is between negative 3 and negative 2, so that one would also be negative 3 still, so this is negative 3. This one's negative 3. Now 0.7 is between 0 and 1, so that one would equal 0. And 1.06 is between these two, so it would equal 1. So when we plotted the points on the graph, it would be negative 3, negative 3, negative 2.9, negative 3, 0.7, 0, and 1.06, 1. And I know that one's probably kind of throwing you off. You're going, wait, that can't be. It's not going to look as weird once we get to the graph and you see what they do. Okay, so now let's go ahead and graph these. If we graph this function, this piecewise, what we're doing is we need to go ahead and graph this line. I say just graph y equals, I'll write it over here, y equals negative x. So from Algebra 1, you should be capable of doing that. This is your slope, a negative 1 over 1, and you have a y-intercept of 0. So you'll go to 0, and then always rise on your slope. I never allow you to fall. There's a reason for that, and I'll explain it in class. But always rise 1, and if it's negative, go left. So now go ahead and plot this line. I'm going to do dots because I can't reach down for my ruler. But you could draw it lightly. Now you do have to use pencil in my class with Piecewise, and here's why. Because now we look at the window. This is what I call the window. What it's saying is, I don't want to see the whole graph. I want to see from less than 0. Doesn't even want to see at 0. So we do a circle where x is equal to 0, and then we go less than, which is this way. And then you erase everything else. Easy way to do that is this arrow tip goes to the left, that arrow tip goes to the left. So just darken that, make it an open circle because it didn't have a line underneath there, and then just connect them. Okay, on the next one. The next one is y equals x plus 1. So my y-intercept is at 1. My slope is 1 over 1. So I rise 1, run 1 to the right. Now I plot this going this way. I can connect those. If you're on your graph and you've got a ruler there handy, go ahead and connect them. You are going to erase, so draw lightly. Now I look at the window here. The window is x is greater than or equal to 0. So this time I go to the 0 and I put a solid dot. The arrow tip's going that way, so I can darken that side and connect those two. Now I erase all the rest of that line. So again, that is, this one was negative x, f of x equals, or y equals negative x. You drew the line, and then you erased according to this window. X is less than 0. You went to 0, open circle that way. Then you said x plus 1, so you graphed that line. You erased it except for this window. From 0, that way. These are not difficult, so if this is seeming difficult, rewind, study this again. Okay, now we're going to look at, whoops, we don't want the word problem yet. Let me see. Now we're going to look at, sorry. I wanted a step function. Here we go. I'll just give you one. This is how a step function would look. Just so that you can see these. So on a step function, you will have f of x, and it'll say like 2, 1, 0, negative 1. And then it might be for x is less than negative 1, greater than or equal to negative 2. And then these just step up. So, f of x equals 2. What that means is that y equals 2. Remember, that is a horizontal line. So we go up to 2 between negative 2 and negative 1. So where x is negative 2 is a closed circle. Where x is negative 1, it's open. So it looks like that. Then f of x equals 1 for negative 1, 0. So that's what this looks like. It just is steps. Now they can even skip a line. You just have to read your code here and see how you're doing it. They could go every other line, but they always form steps, just like a stair step, and you're only looking at the top of the step. Okay, now I'll get on to the other board. Sorry, I wanted to make sure that you understood step functions. Now let's look at my word problem. Mrs. King walks 0.05 miles per hour for 3 minutes, stops 1 minute, and then runs 0.10 miles per hour for 2 minutes. So we could make this into a piecewise function. Distance equals rate times time. You always graph time on your x-axis. So we'll graph our distance going up our y. So I'm going at a rate of 0.05 miles per minute for however many minutes I'm going, and that's between 0 and 3 minutes. Then I don't travel at all. Notice I don't have a rate or anything. This is just y equals 0.15. The way that I managed to get 15, I would give it to you, but you could get it by saying, well, I traveled 3 minutes at 0.05, so I would get 0.15 where I'm standing still. And this is between 3 and 4 minutes. Now the rest of the time, from 5 to 6 minutes, anything greater than 4, less than 6, I'm traveling at this rate. So I could come over and I can graph that. I simply say, okay, at 0, I'm going up, we'll count this as, let's say that's 0.1, 0.2, 0.3, just to make our graph reasonable there. So as we go across here, for the first, this is our time. This is our distance. And our time is in minutes. Our distance is in tenths of a mile because I'm traveling half of a tenth. So in 3 minutes, I'm going up a half on the first, half on the second, half on the third. So from 0 to 3, there's my one graph. I'm just going up at this rate. Then for 3 to 4 minutes, it's like a step function, it's just level. There's no t there. I'm not traveling at a rate. Then for the last 2 minutes, I'm traveling at 10, so I'm going a lot faster. And that would be another form of a piecewise function, because I've got 3 different slopes for lines in that one graph. So you'll see that, I know you used to call them line graphs, just changing the slopes, but we actually want you to see they're different functions now. Last thing that I'll have you do is look at a graph and give me the function rule for it. So I really encourage you to not look at the whole thing, just look at one of these. We know that there's no slope on that line. So we know it's y equals 0, x plus 1, 2, 3, 4. So that could be simplified. Rather than have the 0x, we can say f of x equals 4. Now we need to put the window. X is -1 there, and it's going greater than. So x would be to this side of that, or you could actually, to match your arrow tip up there, I would put the arrow tip that way, put the -1 there, and put x here. That way the arrow tip matches there. You've got your variable on the left-hand side. So I would keep it this way, just for clarity. There is no line underneath because it's not a filled-in circle. So on the next one, you notice the window is from -1 and less than. The arrow tip's going this way. So I would go x less than -1. It is a filled-in circle, so I put the line underneath. Now we need to find the slope. Just count your rise over run. So looking here, it is running 2. It is rising 2. So that would be y equals 2 over 2x. Now I would extend that. It's a 1, 1. I'd extend that, it crosses at 2. 2 over 2 is equal to 1, so I would just reduce that to x plus 2. That is your equation. You do have to be able to find your equations on these and make sure to put in your windows. Not too tough. Let's do a step function, make sure that you're capable of that before class. Oh, my steps kind of wiped off here. Let me just put them back. Okay, and actually on this one I want to skip a line just so that you see how that works. And we'll do it that way. Okay, so first thing I look at is that my y value, it is y equals 0, right there on that line. Y equals -2 there, and y equals -4 there. So I go ahead and I say f of x, that's her formal name, it's another name for y, equals 0, -2, and 4. Now, that looks like a -0. Now I look at my x parameters. Here, I don't have arrow tips, so I need to put it inside. The upper one doesn't have a line under it because it's an open circle. The lower one does have a line. I would just go ahead and fill those in. Now, my upper limit on this x is 3. Sorry if you couldn't read it. And the lower is 2. The upper on this one is 1. The lower is 0. The upper one on this one is -1. The lower one is -2. And that's how it works. Please come into class. We'll practice these during the games, and I think you'll have them. They aren't too challenging once you see the pattern to it. Remember, math is always patterns and relationships.